Another type of combined heat and power, or CHP system, is one that uses an internal combustion engine. And the internal combustion engine is where we pay for some fuel to go into. Yes, it is a carbon intensive fuel that goes into an internal combustion engine, but your good old fashioned internal combustion engine tends to run at extremely low efficiency. And our combined heat and power process tries to harness some of those inefficiencies by using that waste heat. So here's our good old efficient internal combustion engine. And if I were sitting in the room with this internal combustion engine, then that is receiving its fuel in here. This is our fuel. And the fuel costs money, or for, say this is a biofuel facility, lots of different ways to get that fuel in there. But if I were sitting in the room with this internal combustion engine, let's say it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cylinder, large internal combustion engine, what I would notice is, yes, it is loud. And I would notice that it is very, very hot as well. So your internal combustion engine on your car, produces excess heat. Then you turn your heater on in the winter, you're using that excess energy. So there is a type of CHP system where literally you would run a fuel through this internal combustion engine. That internal combustion engine, of course, has the output of work in terms of a spinning shaft, which you could then, of course, do useful work with that spinning shaft, or you can hook it up to a generator to make electrical energy from that spinning work that you had. But instead of letting that heat just get wasted, a CHP, or combined heat and power system, says, let's take the coolant from that engine. So this is a coolant line. And this is going to be hot, right? A hot coolant that runs from an engine. And I'm going to put that hot coolant line through a heat recovery or a heat exchanger, right? Which is my recovery. So I'm going to recover some of that heat. And do something useful with it. What we're going to do with it, I don't know. We're going to do something useful with it. Maybe this is a process that we're going to heat. Maybe we're going to heat the facility that made us the fuel, made us that biofuel in the first place, but it's going to go over here and it's going to be some sort of useful heat supply. It's going to go out into something, and then it's going to do some useful heat energy work, and then it's going to get returned cold after it did that useful work, and then go and get heat up again. What that's going to end up is that it won't, of course, this has to be closed loop, right? So we would close that loop, of course, just like on your internal combustion engine with your radiator. And your coolant would then, of course, have lost some of its energy, goes into your radiator and back to be a closed loop in your internal combustion engine. So this is good. We have recovered the heat from this internal combustion engine from its coolant. But think also of an internal combustion. I said it's noisy. I said it has, excess heat. It's hot. It's also kind of smelly, right? And what's our smelly part? Well, the smelly part is your exhaust. So think about the exhaust from an internal combustion engine. We know that the exhaust is also has some heat energy in it, right? So we can recover that heat energy as well. So this is called a hot water recovery type of CHP, or combined heat and power process. Our exhaust gas then just gets exhausted, right? The exhaust gas literally just gets exhausted here. And then we can use this heat that went through this heat exchanger. So it would look similar to the other one, and perhaps it goes to exactly the same place. Perhaps we are going to that same useful heat supply place and making that facility even more happy, and it will return cold, but it goes and it captures that heat, and it goes into that useful heat supply. So this is a CHP system, a combined heat and power system using an internal combustion engine where, yes, we pay for fuel or we make the fuel, for example, in a biofuel facility, and we recover the heat from the coolant and we recover the heat from the exhaust gas.